All right, so today we're going to be moving on to a new section. Feels like we were in logarithms for ages there, but today we're going to be moving on to conics. And specifically, we're going to be talking about circles today. So really quickly, if you have not watched the YouTube video in your Canvas course, go ahead and pause this video and go back and watch that first. It's going to give you a great overview of what conics are before we move on to really just looking at some key takeaways from conics. So I'm going to let you read these on your own, what conics are. You can tell that conics are the intersection of a plane with two inverted cones, a cone and an inverted cone. So you can see that this plane here intersected with this cone creates a parabola, a circle, an ellipse, and a hyperbola. The video really does a good job of just explaining what that looks like and all of the key features and definitions. So here's our key terms today. Vertex, asymptote, all of these things here, focus, conic section. And today we're going to be talking about circles. So the standard equation, so for a circle, the standard equation for a circle is x minus h squared plus y minus k squared equals radius squared. So let's look at what these things are really quickly and notice that these are not functions, okay? So I'm not going to refer them as a function because they don't pass our vertical line test, right? So if I follow my my vertical line across this circle, it doesn't pass my function test. So it's not a function. They're relations. They're also, we can call them equations as well. So let's define these things. HK is your center, it's the center of your circle. And R is the radius of your circle. So know that this can be also likened to our distance formula. Remember when back in geometry when you learned your distance formula? That's the same thing here for the standard equation of a circle is the distance formula, except there's no square root because it's here. So let's start. I'm just going to write that little note here. So remember when you learned that distance equals the square root of y minus y1, or y2 minus y1 squared plus x2 minus x1 squared? Oof. Same thing. Notice that if you squared both sides, you would get the same thing as the standard equation of a circle. Kind of cool. Just know that you have seen something like this before. So let's look at our example 1. It says write the equation of a circle. So I have a center of -3, 4, and a radius of 6. So I'm going to use the standard equation of a circle up here and just plug in my values. So notice that these are both subtraction, right? So when I plug those in, x minus, this is minus a -3, right? Plus y minus 4 squared equals 6 squared. So if we simplify this, then my equation of a circle, of this circle, is x plus 3 squared plus y minus 4 squared equals 36. Simple as that. All right, let's look at letter B. It says write the equation of a circle in standard form with center at 0, 6, and radius at 1. So same kind of thing. Let's plug it into our standard equation. We have x minus 0 squared plus y minus 6 squared equals 1 squared. So notice that when we're simplifying, x minus 0 is just x. So we have an x squared plus y minus 6 squared equals 1. So notice that when you don't have any number next to your variable here, that value is 0 for your center. All right, let's look at letter C. We'll keep going, maybe increase our intensity here. It says write the equation of a circle in standard form. Here's our center. Is -4, 11, and it contains the point 5, -1. So guess what? We don't know the radius, so we're going to have to use our equation to find the radius of our circle. So that means when I look back at x minus h and y minus k, this is my h and k, and I'm going to use this as my x and y, right? So here we go. Let's try this out. I have x, 5, minus h, which is -4, squared, plus y, -1, minus k, 11, squared equals radius squared. I don't know my radius, so that's what we're going to be solving for here. 5 minus a -4 is plus a +4, so we have 9 squared plus -1 and -11 is -12 squared equals radius squared here. 9 squared is 81, 12 squared is 144 equals radius squared. Get my calculator out because I don't want to be wrong. So we have 81 plus 144. So we have 225 equals radius squared. To find my radius, we'll take the square root, and we know that our radius here is 15. So there's my radius, but I want to know what the standard equation is, right? So I'm going to go back. My x and y I'm not going to use this time, but I'm still going to use my h and k and my radius here to write the equation of the circle. So I have x minus -4, which is a positive, plus y minus 11 squared equals 15 squared, which is 225. You can leave it 15 squared if you want to, or write 225. Either way is acceptable. There's our standard equation. So we do a little work. We had to find out what our radius is, which guess what? You're just finding the distance, right? Same thing that you did in geometry. All right, let's look at letter D. And you can see straight through that, so we're going to go over here. Okay, it says write the equation of a circle in standard form with ends of diameter 5, -3, and 5, 9. So these are the ends of the circle. So we're going to have to use a little bit of a problem solving here to figure out what our center is, right? So, if I have the ends of a circle of the diameter, let's think about what this would look like. That means that one is here, 1 point is here, and 1 point is here. And my center is right in the middle of that. It's the diameter, right? So how do we find the middle of the diameter, right? It's the middle. So go back to midpoint formula. So that's what we're going to use. We're going to do two things here because I need to know my radius too, don't I? So I'm going to use the midpoint formula to find the center. And then I'm going to use that distance formula or the standard form of the equation to find what that radius is. So we're going to do a couple of things here. So let's use our midpoint formula first. Your midpoint is just the average in your x's and the average in your y. So I'm going to write it here. x1 plus x2 divided by 2, y1 plus y2 divided by 2. I'm really just finding the average, right? I'm finding the middle. So let's plug these in. 5 plus 5 divided by 2 and negative 3 plus 9 divided by 2. You could probably already look and tell where that center is going to be, right? Because these are 5 and 5. They're the same x value. But we're going to go through the motions anyway. So we have 10 divided by 2. Negative 3 plus 9 is 6 divided by 2. So our center, we know, is 5 and 3. And you could probably tell that because we knew that it was going to be 5, right? And then we just had to take the average of those, just thinking about that. So our center is 5, 3. We can use either end here as our xy. Let's use this one, xy. And this is hk, just like we did on that last problem, to find out what our radius is. So we'll use our standard form of our equation. So we have x, 5, minus h, 5, squared, plus y, 9, minus k, 3, equals radius squared. That's what we're looking for, right? 5 minus 5 is 0, 0 squared is 0, 9 minus 3 is 6, 6 squared is 36, equals radius squared. So 36 equals radius squared. The square root of that is 6. Notice that I'm not putting positive or negative 6 because it's a radius, right? It's a distance, so we know that it's going to be a positive number. All right, so our radius is 6. Our HK is 5, 3. So now we can write the standard form of the equation here. So our standard form is x minus h, which is 5, plus y minus k, which is 3, equals radius squared, 6 squared, which is 36. So again, you could leave that as 6 squared, or you could write it as 36. Either way would be acceptable. There we go. A little bit of work. If we have the ends, you had to find the midpoint, right? This only works if you have the ends of the diameter. It wouldn't work if you had, points closer to one another. You'd have to do some other things there. All right, let's move on to the back of your notes here, or the other page of your notes, and we'll talk about graphing those circles. So here I'm just going to use the graph paper that I'm given. It says graph the equation of a circle and identify the center and the radius. So now I'm going to be looking at, oh, you can't see that. Looking at my standard form, knowing that this is in x minus h squared plus y minus k squared equals radius squared, right? So I'm just going to pick out those features of my circle. So if it's the opposite value, then my center is going to be 1, 1 here, right? Because it's not that negative, right? So my radius, if it's 1 is radius squared, so think about this, radius squared equals 1 here. So to solve for that radius, I know it's kind of easy on this one, is just the square root of that. So your radius is 1. So that means when we graph, I'm going to start at my center, 1, 1, and then I'm going to count my radius in north, south, east, and west. So I'm going to go up 1, I'm going to go over 1, and down 1. And then that's going to form our circle here. We got a little tiny circle. So that's how you graph that circle in standard form. If you don't have it in standard form, we're going to write it in standard form. So it says rewrite each equation in standard form, then identify the radius and center of the circle. So really quickly, it says complete the square first. Big note on completing the square. You guys did this back in algebra. Completing the square is taking the b value, dividing by 2, and then squaring it. So that's the key feature of completing the square, okay? So let's try this for letter A. We'll see how we can find the standard form of the equation given these values. So step 1 here I want to get my constant on the other side. So I'm going to move this 6. I'm going to write that here. Move the constant as a little step. So we're going to subtract that here. It might take us some lines here to do all this work. All right, so notice that I put extra lines here because this is where I'm going to complete the square. So I'm going to cover up this first one here, and I'm going to say, okay, what's going to complete the square here? So I'm going to grab my 2, and I want to know what this 2 divided by 2 squared is. Well, 2 divided by 2 is 1, and then squared is just 1. So I'm going to add this 1 here. Notice that whatever you add to one side, you have to add to the other. So whatever I add here, I'm going to add on this side. Now we're going to do it for this one. We're going to plug that in here. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Whatever you add on one side, you have to add to the other. So notice that I have created a perfect square trinomial, right? So I'm going to write this in factored form, and you're going to see why we're doing this, okay? So hang tight with me just for a little bit. So factored form is x plus 1 and x plus 1. Factored form here is x minus 3 and x minus 3. And then I have all of this stuff here. So I have a 3 and a 4, or I have a 3 and a 1, and makes a 4. Actually works out nicely. So now if I write this as a squared binomial, look at this. This is really cool how this turns out. Then I have x plus 1 squared. And if I write this as a squared binomial, y'all, sorry, that should be y. Y minus 3 squared. You're like, why did that turn into a y? I mean, why did that turn into an x? It's just my brain. So notice the similarities between what you have here and our standard form of our circle. So that's our goal for completing that square, is we want to write it as a squared binomial. And so in order to do that, we have to complete our square, right? So we can write it as a squared binomial. Interesting how those things come back around, right? So now I want to know what is the radius and the center of the circle. So let's see. The center we know is HK, and its opposite value. So my center is negative 1 and positive 3. That's the center. And then the radius, remember, r squared is 4. So I'm going to take the square root of that, and my radius is 2. So now we have our answer. Our center is negative 1, 3, and our radius is 2. All right, let's see if we can do another one. Here's letter B. And I'm going to leave the last one for us to do together in class. So we have x squared plus y squared plus 6x minus 4y minus 3. Looks like we're going to have to do some reconfiguring to put our x's together and our y's together, and we're going to move that 3 to the other side. So we have x squared plus 6x, leaving room for my completing the square, right? My perfect square on the end. Then I have our y squared minus 4y plus my third value, and then a 3 on the other side. All right, so let's see what's going to complete the square here. I have 6 divided by 2 squared, so that's a 9. And I have negative 4 divided by 2, that's negative 2 squared is a positive 4. So whatever I add on one side, I'm going to add on the other side. I added a 9 and I added a 4. All right, let's go ahead and factor, and we'll simplify this right side here. We have x plus 3 times x plus 3. Then we have a y, making sure to write my y instead of x, y minus 2 and y minus 2 equals 3 and 9 is 12, 12 and 14 is 16. Those are really nice numbers that we're getting. All right, let's write it as a perfect squared trinomial, or I mean a squared binomial, sorry. And we have x plus 3 squared and y minus 2 squared equals 16. Now we have it in the standard form of a circle. So let's identify our center. Remember, center is opposite value. So opposite of positive 3, that's a negative 3. and a 2. That's our center. And our radius, don't forget you have to take the square root because this is radius squared, right? So our radius is 4. All right, there's your answer for letter B. Try letter C on your own, and then we'll do that one together in class, and I'll see you soon.